Greetings, my name is Seth and I'm an integrations engineer with NXLog. In this tutorial series, I am exploring passive network monitoring and logging using NXLog Enterprise Edition and the included IMPCAP module. In this tutorial series, I showcase using the passive network monitoring abilities of NXLog Enterprise Edition to capture and log questionable network-related events such as Rogue DHCP server replies, unexpected ARP and ICMP sweeps, and DNS tunneling. With passive network monitoring, administrators have the opportunity to capture network traffic from devices that are not configured or cannot be configured to forward network activity logs, as well as devices on the network they may not be aware of. In this first example, I will demonstrate how NXLog Enterprise Edition using the IMPCAP module can be used to identify rogue DHCP servers on the network. At best, a rogue DHCP server will cause network degradation and unusual network behavior, and at worst is part of a larger attack strategy against the network. For this example, I will be using NXLog Enterprise Edition to passively monitor all DHCP requests and replies. I will selectively send any unknown or possibly malicious rogue DHCP replies captured to a mock SIM for easy visualization. To begin capturing with the IMPCAP module, I will need to provide the name given to my network device by the NPF driver used in the IMPCAP module. I have defined this at the top of my configuration to make maintenance more manageable in the future. This definition will be used in the primary input section by the IMPCAP module. On Windows machines, each network device will be accessible by the device name assigned by the NPF driver of WinPCAP. This device name uses a prefix specific to the NPF driver in addition to the GUID of the interface. Identifying the correct GUID to use can be done via the command line using the getMac utility and specifying the /v argument. Additionally, the /FO space CSV argument can be given to format the returned list and better display interface names that may appear truncated. On Linux and Unix operating systems, the more familiar interface names like ETH0 or WLAN0 would be used. In this configuration, I will do a few things to filter and reduce the data captured by the IMPCAP module. First, I will add the filter directive specifying UDP port 68. DHCP servers listen for requests on port 67 and reply on port 68. Since I am only interested in replies to clients right now, I don't need to capture the data on port 67. I'm also adding a conditional drop statement to check the value of a specific field in the response from the DHCP servers, specifically the dhcp.opcode field. This means that any DHCP event that does not have the value boot reply in the dhcp.opcode field will be dropped. I will also add the IPv4 protocol and the Ethernet protocol sections to my configuration so that the event data I capture includes data associated with those protocol layers. If I run NXLog and trigger a DHCP event, I see only replies from my DHCP server to the requesting client. In addition, I see relevant IPv4 and Ethernet details, which will be important later. For this example, I don't want to log events coming from known valid DHCP servers, only unknown or rogue DHCP servers on my network. After stopping NXLog Enterprise Edition, I'm going to add a global define at the top of my configuration with 2 known MAC addresses of DHCP servers that I don't want data captured for. I will then use this define in my filter to filter out captures with the whitelisted MAC addresses. As I restart NXLog Enterprise Edition, and trigger another DHCP request event, no replies are sent to the mock SIM, as NXLog now drops them, since the replying DHCP server's MAC address is in my defined whitelist. I'm now going to start a VM that is configured as a rogue DHCP server. Because the VM is running on the host machine, its response time will be much lower than that of my legitimate network DHCP server. My machine will accept the rogue DHCP reply and lease, which will immediately cause multiple network-related issues for my host machine. As I renew my DHCP lease, you can see the rogue DHCP server's reply, since the rogue DHCP server's MAC address is not on my defined whitelist and is therefore tagged as a rogue DHCP server, which can then be seen in the mock SIM. With NXLog Enterprise Edition and the IMPCAP module, I was able to log the rogue DHCP server response and send it to my mock SIM, where I could now act further on that information. For more information and configuration details for the IMPCAP module, I encourage you to review the IMPCAP module section in the NXLog Enterprise Edition user guide. If you have any questions or would like to request a trial of NXLog Enterprise Edition, you can do so online by visiting nxlog.co/request-trial or by contacting our pre-sales team at presales@nxlog.org. In the next tutorial, I will look at how NXLog Enterprise Edition can be used to monitor unusual ARP and ICMP traffic on the network. I'd like to thank you for joining me for this tutorial, and I hope you have a great day.